right. The next thing we need to talk about as relating to solutions is making a dilution. So we have a concentrated solution and then we can dilute it, right? A lot of times, so we made that solution of glucose in the last video, right? But a lot of times what will happen is you'll make a solution that is very concentrated. So you might make a 10 molar solution of glucose. Then all that the doctors and hospitals need to do is dilute that down. You can buy concentrated cleaners at the grocery store for your floor or Lysol, stuff like that. So it's made very concentrated. You bring it home, add water to it to make it to dilute it to the concentration that you need. If you've seen those liquid things of concentrated tea, sweet tea, same thing. They just made it really concentrated, and then you add water to it to get it diluted down so it's at a drinkable place, right? So, dilutions. Scientists can use a more concentrated solution to make a more dilute solution using a process called a dilution. They dilute it down. Right? It just makes sense. Taking from concentrated to less concentrated. All right, here's how that works. So we're back to we made this 2 liters of a 1 molar glucose solution. That's its concentration. Well, we've made that. So we've got the 2 liters of it. You see the 2-liter bottle. So we got about that much of it, right? And the hospital calls and says, okay, well, you take it to the hospital. They're like, all right, what we need to do is we need a 0.25 molarity solution. So we need the concentration to be 0.25 moles per liter instead of 2 moles per liter. And we need it in half-liter containers. So we need a half a liter of a more dilute, less concentrated solution. What do we do? Okay. First step is to calculate the moles of solute. That's the stuff being dissolved, right? So at this juncture, it's our more concentrated stuff. We're going to dissolve it down to a lower concentration. Put it in water. Right? So how many moles for our final solution are we going to need? So we'll put the volume of the dilute solution needed. It was 0.5. And the concentration of the dilute solution, 0.25 moles per liter. That's what molarity is, moles per liter. Okay, and this is liters, 0.5 liters. Liters cancel. We do 0.5 times 0.25, 0.125 moles of glucose. So that's what we need for our finished product. The next step is to calculate how much concentrated solution that has that many moles. How much of my concentrated solution has 0.125 moles in it? 0.125 moles. Because that's what I'm looking for, right? So this is my concentration of the concentrated solution. That's hard to say. Concentration of concentrated solution. So this is my molarity of the concentrated solution. 1 mole per liter. Excuse me. It's written upside down like this, so moles cancel, right? But 1 divided by 1. 1 mole per liter. Is that 1 mole, 1 molarity, 1 mole per liter. So when I multiply and divide here, I get 0.125 liters, which is 125 milliliters, by the way, if we're really doing this. So that is how much of my concentrated solution that I need. It is the volume of concentrated solution that needed. Let's just go volume needed. Okay, so when I come down here, I'm actually going to do it. I'm going to add 0.125 liters of my concentrated solution. You see it. There's this little bit right down here. So I add that in. Then I add water up to half a milliliter, or half a liter, sorry. Stir to mix it all together. And I have a half a liter of the dilute solution of glucose. That's what the doctor was asking for. I was able to mix it all together. I took my concentrated solution, diluted it down to the proper amount. So now again, we can go save some lives.